On a schematic, a solar panel might look like this. You can see it's somewhat reminiscent of a battery, where you see individual cells here. The dots indicate continuation, where more cells would have been present, and the arrows show the solar radiation striking the panel. In this video, we're going to take a quick look at the electrical characteristics of the solar panel. First, we're going to connect a variable resistor to the panel. And then we'll add some instrumentation, a voltmeter in parallel with the solar panel, and an ammeter in series between the solar panel and the resistor. Next, we'll construct a chart. And we'll put voltage on this axis and current on this axis. Now all we have to do is adjust the variable resistor and plot the results. If we adjust the resistor so that there's no current flowing, we'll find that the solar panel has some maximum voltage. And if we adjust the resistor in the other direction, eventually it will short out the solar panel and will arrive at some maximum current. Now if we slowly rotate the resistor and record the values, we end up with a plot that looks like this. You'll find that the current is nearly constant for this portion of the graph. This constant current produced by the solar panel is rather interesting, and perhaps we can explore it in another video. Before we finish, I wanted to talk about power. You recall that power is the product of voltage and current. And it just so happens that we have voltage and current on this graph. In fact, we can superimpose power. We'll add a new axis and call it power. So now our chart has two axes. And let's pick some easy points first. So when we're over here, we know that voltage is 0. So when voltage is 0, we can say that the power is 0. Later, when we're over here, we can say that the current is 0. So once again, power is equal to 0. And since power is the product of voltage and current, and through this area current is constant, we'll see that power increases linearly up until about here. And then it starts to drop back down like so. This is an interesting result. What it tells us is that as we adjust this resistor, we're going to find a sweet spot where the power delivered by the solar cell is at some maximum. In fact, we would call this the maximum power point of the solar cell. In a future video, we'll explore how solar panels are used within larger systems and how those systems are designed to operate the solar panel at this maximum power point. It's called a maximum power point tracker.